building an electronic data acquisition and processing sensor using MATLAB, and we decided to go with an Arduino Uno microprocessor to acquire analog signals from a sensor using a 2-pin thermistor with a 5K ohm resistance to measure temperature in the surrounding area. This data would be measured in quasi-real time, and it would start based on user input. So when the user says start plotting, the data will start collecting based on a switch, and stop plotting, the data would be stop plotting and be saved based on certain process data that the user has inputted. So process data would be mean, standard deviation, maximum, minimum temperatures, range, variance, and mode. So the saving option allows the user to save the data in individual files and access them later.
For our materials, we use an Arduino Uno and a breadboard. The LED on the other side is connected to the ground and pin 13. There is a 5K resistor and 2-pin thermostat. The blue wire is connected to 5-volt pin, the yellow wire is connected to ground, and the orange pin is connected to A0.
Our GUI is the display of the data that we receive from the Arduino that relates back to the temperature sensor. We have a graph that has temperature on a y-axis and time in seconds on the x-axis. Once we flip this switch right here, it'll start plotting in real time and 3 different temperatures: Fahrenheit, Celsius, and Kelvin. And it'll keep going until we ask it to stop. We can switch the graphs to Celsius, Kelvin, or Fahrenheit. After we're done plotting, we have the option to save what we were plotting into our files on your desktop or whatever electronic device you're using to view this. Not only that, the data that we have been graphing and receiving, we're able to look at a range of different statistical data that is available to us. Right now we have the mean available. We can look at the mode, standard deviation for both Fahrenheit, Celsius, and Kelvin.
Another component we implemented was the LED on the Arduino, which flickers on when the system is being ran and flickers off when the user chooses to stop running the system.
As Alexis described, the graph is plotted in real time once the user flips the switch from stop plotting to start plotting. This triggers the lamp on the GUI to turn from red to green, and it causes the LED light on the Arduino to turn on. In the code, this is accomplished through a switch statement where when the plotting switch value is start plotting, the Arduino is initialized and the lamp turns green. Then there's a while loop which keeps plotting while the plotting lamp color is green. As soon as the plotting lamp color changes to red, which happens when the user flips the switch from start plotting to stop plotting, the Arduino stops collecting data, the graph stops updating, and the LED on the Arduino turns off. Within the start plotting case, the voltage value is red from the Arduino, and then using the Steinhardt-Hart equation, the voltage is converted to resistance, which is then converted to temperature. After this, the temperature which initially appears in Kelvin is also calculated for Fahrenheit and Celsius, and then the data is plotted based on which temperature setting the user selects with the drop-down menu. And this is also done with a switch statement. And then all the temperature values are tabulated. Finally, all the data can be saved once the user stops plotting based on another drop-down menu and with the UI save function.